I'd like to present our data on behalf of our lead author, I'm going to present the study result from the Validate J study, which is a validation study of rheumatoid arthritis in Japanese claims data. So, disclosure, this study is funded by Pfizer, and also I'm a Pfizer medical affairs expert. So, background of this study is that claims-based research, database research is relatively new in Japan, and interest in using claims database and other large healthcare database for post-marketing safety studies is growing. RA, rheumatoid arthritis, is the most common inflammatory arthropathy affecting 1 to maximum 2% of the population, and depending on the age distribution. Multiple biologic disease-modifying anti-rheumatic drugs, we call biologic DMARDs, became available in the last few decades, and the safety of these medications needs to be assessed in the real-world population. However, validation of claims algorithms for RA is unknown in Japanese claims data. So the objective of this study is to provide initial result for the validity of claim-based algorithms for RA from Validate J study. Validate J stands for validity of algorithms in large databases, and we include infectious disease, RA, and also tumor in validation. But we're going to present RA results. So this is a method about the study design. This is a cross-sectional study. We choose patients seen in outpatient or inpatient setting at 2 large community hospital clinics during 2012 to 2016. Definition for RA in claims data includes diagnosis for RA, identified using ICD-10 code. Suspected diagnosis was initially included, but we excluded after the pilot analysis. We also excluded psoriasis diagnosis patient using same claim months or plus minus 1 claim month, and also prescription of DMARDs required or steroid prescription required within the same claim month or plus minus 1 claim month. We randomly selected 200 cases for chart review. Trained chart abstractors will review the random sample of medical charts for RA patients identified by claim-based definition. Abstracted information using standardized chart abstraction form. Information was abstracted regarding physician diagnosis of RA and components used for the ACR, ULAR, RA criteria. Extracted information from claims data on also used medication used within the same claims month, plus minus 1 claim month, and other diagnosis within the same claim month, plus minus 1 claim month. Adjudication was performed by 2 independently practicing rheumatologists, reviewed both abstraction form and claims data to determine true uses using the gold standard definition. We first performed pilot study in first 20 cases. The adjudicators independently reviewed both by both reviewers and discussed among the adjudicators and reviewers to establish the process and standards. We defined gold standard definition, 3 gold standard definitions. First one is physician's diagnosis of RA in medical chart. Second is ACR ULAR 2010 criteria. If the patient fulfills the criteria from the medical chart information. Third gold standard we defined as adjudicated judgment based on abstraction from extracted claims data. So for the analysis, we summarize patient demographic, clinical and laboratory characteristics for 200 randomly selected our claims-based cases. We calculated positive predictive value of the claim-based definitions as described below. We contracted with two hospitals, so we required 1 year to have a contract with one hospital and just contracted with another hospital. So in one hospital, the claim-based algorithm identified 2009 RA cases using hospital and bleed claim data from 2012 to 2016. This is a result, characteristic of 200 randomly selected cases. The left row shows the RA cases. We identified 187 RA cases. Age was 62.8 and the female was 75.4%. Mainly identified, 56% was identified in 2012. In biologics, DMARS users were 6% and methotrexate user was 62%. And other non-biologic DMARS 37%. Steroid users were 17%. For shown in the left row, there was 13 cases of suspected RA diagnosis cases. As you can see, the female percentage was very low, and treatment was mainly by steroids treatment only. So we considered this is not similar to the general RA characteristics in Japan. But the RA cases was similar to the general RA characteristics. This shows the RA characteristics related to RA disease activity. So the RA cases show disease duration. 93% of the RA cases showed there was information about the disease duration over 6 weeks. Rheumatoid factor positivity was 58%, and the CCP ACPA positivity was 60%. Also, inflammation laboratory markers such as CRP, ESR was as shown and increased. Tender joint count and swollen joint count was observed. But for the RA suspected diagnosed cases, there was no rheumatoid factor positivity, but showed some inflammation markers elevated, but no tender joint count or swollen joint count was seen. So we consider this as non-RA cases for the suspected diagnosis cases. So we excluded these suspected diagnosis for the main part of the study after the pilot phase. So this is the final result for the positive predictive value. 3 algorithms are shown. The left one shows the algorithm with RA diagnosis plus DMARS. So there was 171 patients identified. The gold standard one from as a physician diagnosis, PPV was 87.7%, and from rheumatologist adjudication, gold standard 3 showed high percentage, 86%, and gold standard 1 and 3 both showed high PPV, and 95% interval was about 80%. Gold standard 2 ACR-EULA criteria, it is previously reported from US PPV validation study as well, but this is the stringent criteria, and the PPV was lower, more than half from both standard 1 or 3. EMARS or steroid, this also showed a high PPV above 80%. But if suspected RA diagnosis was added, PPV dropped about 10% for both standard 1 and 3. So for discussion, so the previous US studies showed that RA diagnosis in Medicare patients using claims data had PPV of 85% when compared with chart documentation of RA diagnosis, as we did. More recently, study in US Medicare data showed a PPV of 86% for claims-based RA defined using 2 diagnoses plus EMARS. Considering the lower incidence of RA prevalence, lower prevalence of RA in our Japanese population than US Medicare population, and only requiring 1 diagnosis, our algorithm performed better, suggesting greater accuracy of claim diagnosis by rheumatologists in Japan, at least in these large community hospital clinics. When suspected diagnosis for RA and steroid were both included to define RA using claim-based criteria, the PPV dropped by about 10%. But when only steroid was included in the definition, PPV remained about 8%. So the limitation of this study would be claim data only is result from the single center, therefore limited generalizability, but we are abstracting data from the second site currently. No formal inter-data variability assessment is currently performed, but we are considering that in the future. Results are only available for RA at this moment, but ongoing validation study will allow us to analyze cancer and certain infectious diseases such as herpes zoster or TB, NTM, or PCP. And also, we are planning a validation study for ulcerative colitis at 2 new centers. So, as conclusion, performance of our claims-based algorithms for RNA had similar or slightly better PPV to that reported in the US. As the Japan Pharmaceutical and Medical Device Agency recently started encouraging validation study to support the validity of database research, validate J may contribute to setting the standard for such validation studies. Thank you for your attention.
So, thank you for this very nice presentation. I'm Sarah from GSK Belgium. And I was wondering what's your rationale for choosing 200 patients or 200 cases for your validation?
We are actually targeting 400 patients. I think standard deviation as shown for the PPV is ranging like plus minus maybe 5% for the 200 cases. So we are expecting much more narrow standard deviation if we correct for 400.
Okay, so but you did not compute the sample size based on exploration of the data, looking at variability and expected prevalence and so on. I mean, I was wondering how you came with this figure of 400 or 200, whether you had a rational, a statistical rationale behind it or not.
So, yes, so estimation to have a PPV more than 80% and standard deviation of plus minus 5% or 10%, we think 400 is enough for having a PPV.
Okay, thank you very much. Thank you.
I'm going to talk about diagnosis-based criteria to identify adverse drug reactions in ICU. Thank you for to all the collaborators. I'm just presenting on the part. So here is the definition of ADR. Because we know there's a difference for in comparing adverse drug events. ADR is more related to to describe something that happening at those are normally prescribed for the patients. So we restrict this this of the drug use. And we know that we can do child reviews, we can do different things. So reading patient reports, and we can do regular data surveillance according to using the ICD coded data. Administrative data is handy. And here's an example for the ICD. Break down the structure, we can see the hierarchical structure for the ICD-10 codes. We can tell some of the code that have specifications for drug-induced conditions. And we just inherit some causality ratings from some other papers. We search the literature. We inherit such ratings and we go through all the codes. Here is the examples of causality ratings, and we can tell from A1 to A2 is highly likely. From B1 to B2 is because they don't mention the drug dose information, so we probably it may be prescribed with the normal dose, or it may be overdosed. I mean, the case has been admitted to hospital because of overdosing. And here, the conventional codes, conventional case capture method is to use external course-based codes, so from Y40 to Y59, and targeting correct drug use. And we have questions. Yes, it's commonly known that if we have two case capture methods, if we use both of them, it's common sense that will increase the incidence estimates, etc. And we want to know what's the variation for the size and say how much will increase from using one to use two methods. And is there any new signals that we can use from one method or from the combination of two methods? And because the details of the methods, etc., has been published in the paper. And here's our study aims. We want to know, you can tell from the three colors, we want to know exactly, the incidence estimates how much the increase will be, and what's the common capture, and also if there are any new signals. For the case step one, we select the diagnosis codes. We review 287 ADR-related ICD-10 codes. We manually search the latest WHO online version of ICD-10 codes, and we also manually search the first drug defense chapter for the CHADEX, and it's published from the Safety Commission in Australia. For case step two, we use the conventional method. We use external course-based codes from Y40 to Y59, and we apply these two methods to the 45R study, cohort study. That study has been linked to the survey, linked to a lot of administrative data sets. So we have no problem of accounting for using de-identified hospital data. Here's the basically results. During the period of 3 years, there were 500,000 episodes of hospitalized care among the study population. Of this, 20% had ADR-related diagnosis codes, and 2% had specified Y40 to Y59 external course codes. That, just a reminder that it has been correctly used drug, have the indications about correctly used the drug. And 0.7 has the diagnosis codes of A1, causality rating that has the drug-induced specification in the codes. Here's the comparison. We can see that using the combination of two methods, we have about 10% incident estimates if we just restrict to those diagnosis codes of A1 and A2 causality rating. If we expand the diagnosis codes to up to C level of causality rating, we may have up there's a misclassification error. So we thought probably 10% is a roughly robust estimate if we use two methods in combination. And here's the conditions captured by external cost-based criteria. And we can tell that if we use external based codes only the conventional method, it didn't perform well to capture mental symptoms, mental disorder, or some other like injury and poisonings. But it did capture almost perfectly the 100% of digestive symptoms. And there are some, we thought probably some new signals of ADR, like constipations, UTR, urinary tract infections, etc. But because we don't have child review, so we only use the codes, so we were unable to verify, the true causalities. We have, Nick, we have Sarah, we have Emily. We have toxicologists, medical clinicians, so we review the codes, but we were unable to review the charts, the patient charts, so we're still unable to confirm if it's really the patients have the ADRs were really in relation to the proper drug use. So we can tell from the research question, we want to know the variation, how much the increase would be for the incidence estimate if we use two methods together. We roughly, using these data sets, restrict to the 45 olds, the older population, it's about 10% increase. And if we use highly selected diagnosis codes, we can capture some, symptoms, adverse symptoms, like that in relation to psychiatric, conditions. And if we validate the combination of the diagnosis codes, that could probably, enhance our capture. It depends on the study context. If someone are going to use the administrative data. And thank you for the study. We appreciate the data and appreciate many thousands of people that joined the study, and also we thank the study founder, Jonathan, Australia. Thank you.
Well, if not, then I ask a question.
Yes.
So obviously, can you elaborate a little bit further on? You mentioned that the mental health condition less representative or valid in your data set.
Yep.
Okay. Could you elaborate a little bit why they meant that? Why is that? It's just the general performance of the codes, or because of some cultural background that the mental health condition doesn't appear as prominently in diagnosis.
Thank you. I think I think the coding issue is one embedded problem for every administrative data set across every country.
Okay.
The coders and the diagnosis, and say for example the opioid users, they may have some mental issues, and probably they would not be categorized as the adverse events and wouldn't be allocated with the external cause codes. That's my understanding. This is the coding issue. The other is probably, again, for opioid use, they may have some other, more prominent or more significant clinical presence that probably attract more attention from the, doctor in charge than in the prescription in something else. People say relate the mental problem to the drug use, and sometimes even opioid use hasn't been identified in the say administrative data sets. But if we use narrative data sets, we may have to be able to identify opioid use that we can say this case is related to opioid use. But we limitation. Thank you, Alan.
Thank you.
Good morning, everyone, and thank you for this opportunity to present our research. My name is Sun Xin, and I'm a master student at Peking University, and my supervisor is Professor Zhang. This study is a systematic review focused on the accuracy of molecular diagnostic tests for the detection of drug-resistant tuberculosis in China. First, I'm going to talk about the background. Tuberculosis is a serious global health problem. According to the WHO report, an estimated 10 million people developed TB in 2017, of which 558,000 were MDR TB cases. China is one of the highest TB burden countries, with nearly 889,000 TB cases and 73,000 MDR TB cases. There are two kinds of diagnostic techniques for drug-resistant TB. Traditional culture-based DST relies on the cultivation of bacteria, which prolongs the diagnostic time and therefore impacts the selection of appropriate drug in time. Molecular diagnostics can detect the presence of specific genetic mutations responsible for drug resistance. It's a rapid and accurate method to detect the pattern of drug resistance. In China, 4 TB molecular diagnostics are available in clinical practice. They are expert, LPA, J&J, and multiple TB assay. In recent years, some studies have reported the accuracy of above assays, but the overall evaluation concerning the diagnostic value of these assays in Chinese patients is lacking, which is necessary to inform policy decisions on the use of molecular diagnostics. Therefore, this systematic review aimed to evaluate the accuracy of TB molecular diagnostic tests for the detection of resistance to first-line and second-line anti-TB drugs in Chinese patients. This is because of our study. We chose Chinese adults and children with confirmed TB and suspected drug-resistant TB as study participants. Index tests for molecular diagnostics approved by CDE, rapid standard or culture-based DST. What can be considered was the accuracy, including sensitivity and specificity. We performed a comprehensive search of 3 English databases and 4 Chinese databases, using the search terms of tuberculosis, the trade name and generic name of molecular diagnostic test, China, and so on. The inclusion criteria were strictly limited in the following 7 aspects. The whole process was strictly in accordance with the standard step of systematic review, and we use CODAS tool to assess the quality of each study. First, we perform descriptive analysis. The observed sensitivity and specificity of each study was described in the forest plot and RC plot. The meta-analysis was conducted by type of index test and drug resistance if there was no substantial heterogeneity between studies. If at least 4 studies were available, we used the bivariate random effects model to power the estimates. If not, we use univariate random effects model to calculate sensitivity and specificity separately. In addition, we performed sensitivity analysis for CODAS 2 items in order to explore robustness of study results. A total of 5,933 unique records were identified from the literature search after strict screening according to the inclusion and exclusion criteria. We finally included 159 studies in this systematic review. This figure shows the quality assessment result of all included studies. We focus on the diagnostic accuracy of 4 TB molecular tests. results of expert assay as an example. A total of 39 studies report the diagnostic accuracy of expert for wave resistance detection. Sensitivity ranged from 71% to 100% and specificity from 91% to 100%. Summarize the meta-analysis results of accuracy of this for molecular diagnostics. Compared to the ST as the reference standard, experts can diagnose wave resistance TB quite well with the port sensitivity and specificity of 92% and 98%. LPA also performed well for wave resistance detection with the port sensitivity of 91% and specificity of 98%, but not for INH and second-line drugs due to lower sensitivity. The port sensitivities of J&J for wave, INH, and MDR were 89%, 79%, and 79% respectively, and the port specificities were all more than 97%. And a similar condition was observed in melt crew, even though only a few studies have reported the accuracy of this assay. We evaluate the robustness of accuracy in the following aspects. This sensitivity analysis made little difference to any of the findings. In summary, this meta-analysis indicates that all these assays are credible methods for detection of wave resistance with good sensitivity and high specificity, but they perform suboptimal for detection of resistance to INH and other anti-TB drugs due to lower sensitivity. The higher diagnostic value for wave resistance could be attributed to the fact that wave resistance is detected in a more specific and limited generic region than for other drugs. RPOB gene mutations are the main reason for wave resistance, which caused more than 95% cases, while for other drugs, target mutations are more complex. The generic basis of molecular diagnostics may not be sufficient to cover all these potential mutation sites, which could explain the lower accuracy for other drugs. In addition, compared with previous review, we found lower sensitivity for INH resistance detection. This may be due to the population restriction in our study. Studies have found that the frequency of gene mutations associated with drug resistance appear to differ quite significantly by geographic region. The Western Pacific region, including China, had the lowest frequency of the KIT-J and INHA mutation, which suggests the poor performance using molecular diagnostics to detect INH resistance in this region. There are several limitations in this study. First, a large proportion of studies were high on clear bias. Second, the influence of some factors could not be analyzed since the information was not available. Third, few studies assess the accuracy of different molecular diagnostics on the same samples, providing insufficient data to conduct direct head-to-head comparative studies of accuracy. In conclusion, these four assays can inform clinicians about drug resistance patterns of TB patients rapidly. However, since discordance still exists between conventional DST and molecular test, we suggest including more target genes in these molecular techniques to improve the sensitivity. We recommend that the molecular diagnostic might serve as an earlier guide for TB treatment until DST results can be administered. Thank you for your attention.
I understand that you had 159 studies in your meta-analysis, is correct? And 71 articles. Is that correct? Could you just, maybe I missed it, I'm wondering about the heterogeneity I squared or tau, which might have been associated with the meta-analytic approach to these studies that you aggregated together?
Thanks for your questions. They assess the heterogeneity by virtually in the forest plot and Argus plot, and we found the distribution in forest plot is centralized. So we think maybe there's little heterogeneity in the studies, and we also do some subgroup analysis to solve this problem. Yeah.
Subgroup analysis and a visual inspection of the distribution.
Thank you. Would you consider doing some statistics on the applicability of aggregating this data together? Normally speaking, we might expect to see an I squared or a tau which would estimate the correctness of being able to aggregate data together. Thank you.
有没有做那个统计的这个检验？
That's fine. That's fine. Thank you.
We have time for one more question. Well, if not, then let me ask a question. China is a very big country. Are there regional variation in drug resistance in different parts of the country? 我用中文讲，就是中国很大，那这个会不会有没有地理位置上面的这个创造性的差异？ Okay. So, sorry.
The answer.
My question was, are there regional variation with regards to prevalence of drug resistance? Because China is a very big country, and the answer was, there was no special attention paid to that in this particular analysis.
Hello everyone, my name is Wang Yaobing. I come from Peking University in China. My name is very easy to remember. It's my honor to share the same name with the first Prime Minister of Singapore. Yeah, Wang Yaobing. So this is my second time to join the ACP conference. Thank the ACP committee for giving me such an opportunity to present my work. Today, I'm going to talk about DPP-4 inhibitors and risk of inflammatory bowel disease among patients with type 2 diabetes, a meta-analysis of randomized controlled trials. We have no actual or potential conflict of interest in relation to this presentation. The content has 4 parts, including background, measures, results, and clinical perspective of our study. At first, let's look at the background of our study. Inflammatory bowel disease is a family of chronic immunologically mediated disorders that result in the inflammation of the gastrointestinal tract, which consists of 2 main pathologies, including disease, CD, ulcerative colitis, UC. Recently, the BMJ published the results of a retrospective cohort study, which found that the new use of DPP-4 inhibitors was significantly associated with an increased risk of inflammatory bowel disease, IBD. The study involved 141,170 patients during a median of 3.6 follow-up years with hazard ratio of 1.75. However, some animal studies show different effect. It shows that DPP-4 inhibitors may decrease IBD activities and severities through inhibition of T-cell proliferation and inhibition of cytokine production. Certainly, it also exerts its effect on restoration of gut mesenchymal damage. So, what is on Earth the association between DPP-4 inhibitors and the risk of IBD? Considering the difference between clinical and animal evidence, we performed a meta-analysis to evaluate the potential link between DPP-4 inhibitors and the risk of IBD among type 2 diabetes. Now, let's move on the methods of our study. We firstly systematically searched for electronic databases, including PubMed, Embase, the Corporate Central Register of Controlled Trials and Clinical Trials, from inception to April 28, 2018. The search terms included DPP-4 inhibitors, type 2 diabetes, and so on. Our main outcomes include IBD, CD, and UC. They were strictly identified using preferred terms from medical dictionary for regulatory activities. It is version 21st. This is our inclusion criteria, mainly including patients with type 2 diabetes, DPP-4 inhibitors versus placebo or other active anti-diabetic drugs. Reported incidence of IBD, including CD and UC. We excluded unspecified colitis events due to the non-specific or heterogeneous nature of these diagnoses in clinical practice. Now, I would like to show the results after study selection for 616 non-relevant cohorts identified. A total of 6 randomized controlled trials were included in the meta-analysis. This is the table of the baseline characteristics of the included trials. We found all 12 were 2-group trials, including 5 placebo-controlled trials and 1 height-to-height trial. It involved 41,509 patients. The range of mean age was from 57.2 to 65.5. The range of HbA1c was from 7.1 to 8.7%. The range of mean duration of type 2 diabetes was from 5.2 to 12.1 years. This is finger of quality assessment of included studies. All studies had high risk of reporting bias because ICD events were not reported as endpoints when they designed trials. However, the trials included had a low risk of other bias. This is results of meta-analysis. Overall, use of DPP-4 inhibitors was not significantly associated with an increased risk of IBD compared to control drugs. No statistical heterogeneity across studies was observed in the analysis. We also performed a sensitivity analysis using a number of person years. We found that the results of IBD risk were consistent with that of the primary meta-analysis. We used funnel, plot, Beggars, and Eagles test to detect any potential publication bias. Finally, no bias was detected. Even though no increased IBD risk was detected based on meta-analysis of available RCTs, IBD events might be monitored and reported for DPP-4 inhibitors users for the limitation of our studies. Firstly, limited number of included RCTs, because only 6 trials were included. Second, scan data in each RCT. The rate of IBD events in each RCT is very low. Thirdly, ignorance of IBD events in trials, because IBD outcome is not predefined as endpoints, so maybe it is underreported. More studies should be performed to evaluate the IBD risk related to DPP-4 inhibitors. Thank these people for their help.
If my memory is correct, in the original paper published in BMJ, they said 6 months of lag time, correct? And in sensitivity analysis, they said 1 year as lag time. Did you take into account the possibility of the delay of the occurrence of the effect?
I'm sorry, I didn't get it.
Alright, 原来在念卷那篇 paper 有考虑到用药6个月之后，甚至1年之后才会发生 IBD。那在这个临床试验里面有没有考虑到这个时间的这个关系啊？因为如果要发生这个事件的话，可能需要用药的时间会比较长，6个月或者1年。所以问题就是说，在临床试验里面有没有考虑这个？
Oh, and we know the results from the BMC journal, they consider these issues. And in our study, the follow-up duration is from 3 to 36 months. But the number of included trials is very limited. It also reminds us the clinical evidence is very, it's alike. Now, so we don't have enough evidence to perform subgroup analysis. Yeah, maybe in the future, if we have more evidence, we can do this research. Yes, thank you.
Good morning. My name is Hanol Jung from Sungkyunkwan University, South Korea. And my presentation topic is Prescribing Trend of pioglitazone after Safety Warning Release in South Korea, a population-based interrupted time series study using a nationwide healthcare database from 2009 to 2015. The authors declare no conflict of interest. Pioglitazone is a drug of the TZD class used to treat type 2 diabetes. It's an anti-hyperglycemic agent which increases hepatic and peripheral insulin sensitivity. Several studies have reported an increased risk of bladder cancer with the use of pioglitazone. Hence, in 2011, upon results from various studies reporting this risk, multiple regulatory bodies around the world have released safety warnings. And accordingly, South Korea's Ministry of Food and Drug Safety also released a safety warning, delivering parallel concerns on June 10, 2011. Therefore, the objective of this study was to explore the number of pioglitazone and other anti-diabetic drug users before and after the pioglitazone safety warning release by the MFDS by using an interrupted time series study design. For this study, the National Health Insurance Service National Sample Cohort Database was used, where it is composed of approximately 1 million people that were randomly extracted from the entire Korean population. The database contains patient characteristics, diagnosis, and prescription information, where the patient codes were anonymized and diagnosis codes were in ICD-10. For this study, an interrupted time series study design was used, where this is the strongest type of quasi-experimental research. It is widely used when evaluating the effectiveness of population-level health interventions that have been implemented at a clearly defined point in time. The ITS study design statistically tests for a variation in the outcome rate in the time periods before and after the intervention. And it is particularly useful when randomized research is not feasible or reckoned unethical. The graph on the left shows a hypothetical example of an intervention to reduce medication error rates. The figure here shows our study design where there were 30 months and 54 months worth of data before and after the intervention from January 2009 to December 2015. Our study subjects were composed of all those aged 18 and above, had a diagnosis record of diabetes at least once in either an inpatient or outpatient setting, and also a prescription of an anti-diabetic drug between January 2009 and December 2015. All those younger than 18 were excluded. This figure shows the study subject selection flow chart where from approximately 1 million people, from 1 million people to start with, upon excluding for age less than 18, people without diagnosis records of diabetes and no prescription records for anti-diabetic drugs. Our final study subject was comprised of 80,000 people, and for the period before the intervention, from January 2009 to June 2011, approximately 55,000 people were included, and for the period after the intervention, approximately 74,000 people were included. Exposure was set as before or after the intervention, and outcome was the number of drug users according to the WHO ATC codes. Pioglitazone was our main drug of interest, and for comparison, rosiglitazone, sulfonylurea derivatives, and metformin, DPP-4 inhibitors, GLP-1 analogs, and insulin analogs were included. For potential confounders, age, gender, medical institution types, comorbidities were included, where the medical institution types were classified according to the number of beds, and ICD-10 codes were used for comorbidities. For statistical analysis, the proportion was calculated by each month, where the proportion was the number of pioglitazone users divided by the total number of DM patients. And also the absolute and relative change in proportion of pioglitazone and other anti-diabetic drug users before and after the intervention was calculated, and its 95 confidence interval was calculated as well. As this study utilized an interrupted time series design, a segmented regression analysis was used, where Y represents the number of drug users, and beta 1 represents the slope, regression line slope before the intervention, and beta 2 represents the immediate change of the number of drug users after the intervention, and beta 3 represents the regression line slope after the intervention. Furthermore, ordinary least squared regression and maximum likelihood estimation was used to calculate the number of drug users per month, and segmented regression, as stated before, was used. For seasonal and time trend adjustment, autocorrelation was checked using Durbin-Watson statistics, and seasonality or stationarity was checked using Dickey-Fuller unit root tests. Table 1 shows the baseline DM patients and pioglitazone users' characteristics. From a total of 80,000 people, diabetes patients, 12,249 were pioglitazone users, where this accounts to approximately 15%. And males were more males, and those under 50 and users of primary care clinics were users of pioglitazones, and they had almost half of the pioglitazone users had hypertension as their comorbidity. Table 2 shows the absolute and relative change before and after the intervention. Pioglitazone had a relative change of negative 8.13 and an absolute change of negative 1.04. For rosiglitazone, it had a relative change of negative 99.82. For sulfonylurea and metformin, 0.29. DPP-4 inhibitors and GLP-1 analogs, 209.03, and for insulin analogs, 18.81. This shows the secular pattern from 2009 to 2015, where this line shows when the intervention was implemented. For sulfonylurea and metformin, there was rather a constant trend, so it was rather a plateau. And DPP-4 inhibitors and GLP-1 analogs showed an overall rising trend. For rosiglitazone, it showed a decreasing trend and dropped to 0 at September 2010 because it was withdrawn from the market. And for pioglitazone and insulin analogs, it showed a rather very slight decreasing trend over time. This shows the results of the segmented regression analysis, where for pioglitazone, the variable beta 2 represents the immediate change after the intervention. There was an immediate 177 decrease in number of pioglitazone users after the pioglitazone safety warning released by the MFDS, and this was statistically significant. This shows the time secular pattern for pioglitazone on its own, where the part here shows the actually observed number of pioglitazone drug users before the intervention, and the gray is the actually observed for after the intervention. If the intervention had not been implemented, it would have shown a predicted pattern represented here by the green line. And sorry for the mistake, but this should be the upper and this should be the lower. So if the intervention was not implemented, it would have reached approximately 90 pioglitazone users per 1,000 DM patients, where the intervention halted this increase. Sensitivity analysis was done by applying a 3-month lag period to both before and after the intervention, and despite the lag period of application, similar results were seen. So, upon release of the pioglitazone safety warning on June 10, 2011, a moderate decrease in the number of pioglitazone users was shown, despite the numbers actually decreasing prior to the intervention. Regardless of the intervention, pioglitazone still accounted for 11.73% of all antidiabetic drugs, showing only a minor absolute reduction of 1.04%. A study conducted in France reported a decreased incidence of first-line non-insulin glucose-lowering drugs, especially TZDs, from 2006 to 2013. Without the safety warning, pioglitazone users would have steadily increased, but rather the intervention halted this potential increase and led to a continuous decrease. So through this study, the safety warning intervention was found to be effective in successfully decreasing the number of people using the warned drug, which would have eventually led to a decrease in the incidence of adverse outcomes or side effects from drug utilization. The strength of this study is that this is the very first population-based study done in South Korea to examine the temporal trends in the prevalence of pioglitazone users before and after safety warning in June 2011. And also we utilized a nationally representative NHIS NSC database, which underwent strict, systematic, stratified random sampling. As for limitations, the number of drug users should not be interpreted as the actual real-world use among diabetes patients, as non-compliance may lead to an overestimation of drug use. And other interventions besides our main intervention of interest may have influenced the number of pioglitazone users. In conclusion, the pioglitazone safety warning issued by the Ministry of Food and Drug Safety of Korea led to a moderate decrease in pioglitazone users. Despite findings, those with high potential risk of bladder cancer should either be prescribed with pioglitazone in careful attention or seek alternative treatments. Thank you for your attention.
So I had 2 questions actually. I'm not sure whether I missed it in your presentation. So you say, or maybe I'll start with my first question. It's similar to the very first question I had in this session. So it was regarding the sample size, the 1 million population you selected. So I'm not sure how you decided on this. Was that because it was the only population available, or did you have a...
To answer the first question, the database we used was the total number of people in the database is 1 million people. It's a 2% sample database from the entire Korean population.
Okay. Okay. So that's the population. It's It's the whole population of ADHD?
Yes.
Okay, great.
And it's a well-representative data of the entire human population.
Okay, great, thanks. And then the other question I had, so I understood you took into account the confounders.
Yes.
So age, gender, and medical site as well as comorbidities.
Yes.
So I was wondering, because you, in the results, it seems like you present an overall trend for, so I was wondering what was your regression approach? Did you use, did you take into account the within and the between variation of those confounders? Did you define them as class variables? And I'm not sure if you understand my question.
Oh yes, we classified them as categorical variables and were included into the segmented regression analysis.
Right.
So
but did you derive strata-specific estimates, and you pooled all your estimates to come with this combined value? Because you come up with just one decrease you see for per medicine. So I'm not sure if you understand. Otherwise, I can ask it during the break.
For this segmented regression analysis, we conduct this set in SES program. The variables for these data 1, 2, 3 are given, and these are the main variables of interest. So if you put the other confounders into the model, they're automatically adjusted for.
Okay, so that was my question. So you took into account in an overall estimate. Okay, great. Thank you. Thank you.
Okay. Frank slightly beat Yoshi. So.
Thank you. It's a wonderful study. Thank you very much for doing this work. Very interesting. This is an ignorant question, as most of mine are. Can you tell us why you didn't include people under 18?
We thought that those under 18 would be very low in prevalence of diabetes, so we excluded them.
Thank you. I'll pass it to Yoshi. Thank you very much. It's a great.
One more question afterwards. Okay.
Kyoshi from Japan. Could you show me the graph or the trend of the news?
Next one.
The next one. Yeah, this is better. To my eye, it seems the decrease already began.
Yes.
About 2-3 months before the warning, and my general observation is safety warning made by the regulatory body itself seldom is effective, and rather with the combination of other factors it may be effective. Then I guess some news or some information was already distributed to healthcare professionals before the safety warning was issued by the regulatory body. I think this explanation may be a bit more realistic. What do you think?
To answer your question, I prepared a figure where
well prepared.
The reason for the potential early decrease was maybe due to results from studies showing the risk of bladder cancer and pioglitazone use prior to the safety warning release. So I think the physicians were aware of this information and were in careful use when they were prescribing pioglitazone to diabetes patients.
Okay.
Good. Yes.
I have a question. Very interesting in your topic. Another graph about your sensitivity analysis. I have a question about your time period. How to define this time period?
3 months.
I noticed your 3 months. If I want to do the similar study, so how to define this period?
It's not shown here, but we tested 1 month, 2 months, and 3 months, but they all show similar trends. So we thought that by applying that period, the longest period would be representing that this intervention did not really really had an effect on the number of pioglitazone users. So we showed the results with the longest time period. We tested various periods.
So it depends on different disease. I say if I want to do the similar method of ITS model, I want to do the sensitivity analysis, it depends on different topic, different disease to define the period.
I think it would depend on the research. I think it's very subjective.
I mean, if you can do different choice for different period, maybe it's better for your study. Why you only choose one period to do the sensitivity analysis?
We only show the raw results from our presentation.
Oh, so just to show this?
Yes.
Okay, thank you.
Yeah, so the question was on how best to approach sensitivity analysis in a segmented time series analysis. So the response was actually they try 1 month, 2 months, 3 months, and then show the results for
Today I will introduce a research of our group named the Neurological Manifestation of Incretin-Based Therapies in Patients with Type 2 Diabetes, and it is a network meta-analysis. Okay, first I will introduce a brief introduction of the active diabetes. In 2017, there were 425 million adults living with diabetes, and this figure will rise to 629 million in 2045. Well, our research focused on a kind of new anti-diabetic agent, the incretin-based therapies, and it has two kinds of medicine, the DPP-4 inhibitors and the GLP-1 receptor agonists. Well, talking about the mechanism, the DPP-4 inhibitors can prevent the rapid degradation of GLP-1 so that it could enhance the pancreatic insulin secretion, thus suppress the pancreatic glucagon and protect beta cell function. For the GLP-1 receptor agonist, it could promote the insulin secretion and improve the insulin resistance so that it may slow down the gastrointestinal motility. Up to now in the market, there are 5 DPP-4 inhibitors and 5 GLP-1 receptor agonists being approved by the FDA. The objective of our research is to evaluate the effect of these kind of anti-diabetic drugs on dizziness and headache in patients with type 2 diabetes. We only focused on 2 symptoms of the neurological manifestation. And then I will give some brief introduction to the network meta-analysis. It is also called the mixed treatment comparison meta-analysis and the mixed treatment comparison meta-analysis. We can see this figure in traditional pairwise meta-analysis. In traditional pairwise meta-analysis, we only need to include trials compared A and B, but in a network meta-analysis, we need to include all the treatment or the interventions over targeted disease like C, D, and E. And in these situations, there are no direct comparisons between A and C, so we need to use some bridges like the B, D, and some other 3 or 4 loops to evaluate the indirect effect. And then the 3 important hypotheses in network meta-analysis. First is the heterogeneity. It is just like the pairwise meta-analysis. We need to make sure that all the trials with the same populations are similar. And then the similarity. Look at this figure. If there are no direct comparisons between B and C, so we need to calculate the effects through A. So the trial characters of AB and AC must be sufficiently similar so that the effect can be transferred. And then the consistency. When there are both direct and indirect comparisons between B and C, so we could have the direct and the indirect results. So these results need to be having agreement with that done separately. We have already registered our research on the cross-barrel, and we did several data analyses, including the direct, the indirect, and the mixed comparisons. And we also examined the assumptions in the network meta-analysis. We also did the sensitivity analysis, the subgroup analysis, and the math regression to evaluate some confounders or some factors which may include the study results. For the quality assessment, we used the Cochrane risk of bias to evaluate the randomized controlled trials in our study. And for the evidence, to evaluate the evidence of our study, we used the grid. For different study designs, there are different criteria. And here in the grid for the randomized controlled trials, there are 5 degradation factors. The study limitation, the indirectness, the inconsistency, the imprecision, and the publication bias. Here is some basic information of our results. Finally, we included 232 trials, including about 146 participants. Among these trials, 141 reported the outcome of the disease and 209 reported headache. And also some information about the publication years, the trial duration, the mean age, and so on. This is a flowchart of our study. At first, we searched more than 16,000 titles or abstracts from different databases. And then finally, we include 232 trials. This is one of the main results of the network meta-analysis. It is the network plot, which can show the overall structure of our study. The whites of the lines, we can see the whites of the lines represents the number of the RCTs for each pairwise configuration, and the node represents the number of the randomized participants and also the sample size. The yellow lines represent the trials with unclear risk of allocation concealment, and the red represents the low risk. This is a figure about the general risk of bias results, and I only show the results of dizziness here, and it's just similar to the headache. We can see that except for finding in other 6 domains, the majority of the included studies are all considered as low risk of bias. This is another main result of the network meta-analysis, the effect of mixed comparison and direct comparisons. The results of the network meta-analysis, the mixed comparison were listed in the lower triangle, and the estimations was calculated as a column defining treatment compared with the row defining treatment. For example, the 1.46, we can see that it means that compared with the insulin, the DPP-4 has a higher risk of dizziness with an estimate of 1.46. And the explanation in the upper triangle, it is a direct effect of the trials, and the explanation is opposite to the mixed comparison. It is one method to evaluate the inconsistency of our network meta-analysis. We can see that most loops, all the loops were consistent according to the confidence interval. But we should be cautious because there are some outliers larger than 2, which means that the results of the direct comparisons are more than 2 times of that the indirect comparisons. However, we also did some other method. We also used some other method, including the node splitting model, to evaluate the inconsistency. but they show no significant difference in direct and indirect operations. We also did the global inconsistency, and there are no difference between the consistent and inconsistency model. This is the method to evaluate the heterogeneity. The predictive intervals indicate that no configurations have estimated heterogeneity in these needs, and the result is seen in the headache. This is the film plot to evaluate the publication bias. Now, according to this figure, we can see that maybe there is some publication bias in the outcome of disease, and for the headache, the film plot was quite symmetric. Maybe there are no publication bias. This is a cumulative probability, and we listed them in this table. It shows the ranking probability of safety on both dizziness and headache. We can see that the DPP-4 inhibitors and the GLP-1 receptor agonists ranked lower among the 9 treatments with the probability listed here. This is two-dimensional graphs about both two outcomes, and the drugs in the top right corner may have a higher risk in both headache and dizziness. This is the main results of our studies. The GLP-1 receptor agonist increased the risk of dizziness and headache compared with the insulin, TZD, or placebo. And the DPP-4 inhibitor increased the risk of headache and dizziness compared with insulin. For the ranking probability, the GLP-1 receptor agonist performed worse in reducing the risk, while the DPP-4 inhibitors ranks in the middle. The results of GREAT shows that our results or our evidence ranged from very low to high, and the most configurations were rated as moderate. There are other 2 large cohort studies with sample size more than 1,000 participants showed that the GLP-1 receptor agonist has a higher risk of dizziness than the DPP-4 inhibitors, and it is just the same as our results. For the mechanism, maybe it can be explained in two aspects. First is that diabetes, and then maybe these kind of drug can cause such symptoms. And for the conclusion, the incretin-based therapy seems to increase the risk of dizziness and headache compared with these 3 traditional drugs. And so then I think these should be emphasized by the physicians, and maybe in the future guidelines, we should pay more attention to these symptoms because they may lead to the lower rate of compliance of the patients with type 2 diabetes. Okay, that's all. Thank you.
Frank May from Australia, thank you very much. There is a lot of controversy with regards network meta-analysis, with regards its usefulness, and it's because it relies on a very large number of assumptions of linearities, as you pointed out. I'm wondering if you'd like to comment on your view of how helpful network meta-analysis has been in trying to sort out who might suffer dizziness in relation to diabetes therapy. How useful do you think meta-analysis, network meta-analysis is, given your experience with this technique and in relation to other more conventional methods of understanding the different side effects from medicines? Sorry, it's a question about what you think network meta-analysis, how useful is it as you have experienced it?
Well, to be honest, I think at present most of the network meta-analysis are done only for one outcomes or two outcomes like this. But I think the function of the network analysis is limited at present. And maybe I think in the future we need to do some, I think maybe we need to consider both of the risk and the benefit of the drug so that it can be used by the physicians more efficiently. So that I think in their daily work, they want to know whether a drug can be used to their patients instead of they only focus on one symptoms. So it is our next research, and we hope to do some. We hope to include more outcomes of the network meta-analysis, and maybe they are not limited to one or two outcomes, and we hope to do an overall risk and benefit evaluation of a certain drug. Thank you.
Thank you for good presentation. My comment is somewhat related to Frank's point. Let me see the ranking of the drug showing graph of each DD drug. Let me see the result of the ranking of the drug.
The ranking graph.
This is. I wonder why placebo is fourth rank. The ranking of placebo is fourth.
安慰剂排第四。
I think maybe it is limited to the number of the clinical trials. For example, the SGLT2. Although, I think it is maybe limited to the number of
Yes, my point is, I believe placebo is the most safe drug among the active treatment. So I understand that DPP-4 and GLP are related to dizziness and headache. But the conclusion should be in comparison with placebo, and the risk of other drugs with similar
you think that placebo should rank the first drug?
Yes.
There are limited studies in SGLT2. It is only one study there, so that it may have some bias.
它的问题是 placebo， 它的问题是 placebo 好像不应该有副作用。
但是but because you can see that. These plots placebo and compared with some other drugs, there are limited numbers of the control trials, so that maybe our result is not similar to real situations.
Yes, I understand it, but the most strongest evidence is that GLP and DPP-4 are at higher risk than placebo in this data. So the first conclusion should be saying that without comparing active and active drugs.
他的点就是说应该是 so let me rephrase your point. So your point is that the focus should be active drug versus active drug. Is that true? Or is it active drug
I'd like
versus?
to separate active and active comparison and active and placebo comparison. I'd like to separate active and active comparison and active and placebo comparison.
他的目的就是希望说，一个药跟另外一个药的比较， 跟一个药跟安慰剂的比较就分开